So I want to demonstrate how to do the review part 2 homework. So when you open IntelliJ, just create the new project. So for this project, we're going to put everything under review part 2 because all those files are going to go into one project. So I'm going to click finish. So now what I want to do is inside the source folder, that's where I'm going to put my blueprint classes. So I'm going to go ahead and create the files inside of here. So right click, new Java class. I'm going to create the dog class and I'm going to create the sphere class. So it's really easy to create blueprint classes in IntelliJ. Blueprint classes are also known as POJOs, which stands for plain old Java objects. So the first thing we need to do is we need to figure out what our instance data is going to be. So if you read the instructions from the book, we have a name and we have an age and we have a human years, but the human years is actually calculated off age by multiplying age by 7. So it's a common mistake to add this as instance data. Since this is a calculated value off age, we do not need instance data for human years. So the instructions from the book tell you to create a constructor that accepts a name and an age to initialize the dog object. So you can go ahead and type out your constructor, but IntelliJ, it makes it really easy for us to do this. This is what we call boilerplate code. Boilerplate code is things that's constantly done in blueprint classes. So if you just right click inside of your dog class and then go under generate, you can select constructor, then select the instance data variables that you want your constructor to accept. Hold shift to select both and press OK. So it generated my constructor for me. So this constructor is going to accept name and age and then use the values that are passed in to set the instance data to the name equal to what was passed in and the age equal to what's passed in. You can do the same thing that we just did for the constructor for the getters and setters. Just select getter and setter and use shift to select both. Press OK and it generated my getters and setters. Now the one method that we do actually have to write is a method to get human years. So I'm going to go ahead and create that. And human years is just age times 7. Now, if you actually read our coding standard, we shouldn't use literal values. So I'm going to go ahead and create a constant that's going to have the factor for human years. So here's my constant. I made it public, static, final. It's an integer, and I named it human years in all caps because it's a constant. If you read our coding standard, anytime you use a constant, it should be in all caps. So I'm going to use that instead of using 7 inside of this method. So 2 other requirements that you have to do for every blueprint class you create in our course is to override the Tostring method and to override the equals method. So to do that, just right click, go to generate, go to override methods, and then click on Tostring and use control to also select equals. So in this course for blueprint classes, you also have to create Java documentation. Avoid hitting this here. It's going to be a whole bunch of documentation that you don't actually need. I'm just looking for simple explanations for the Java documentation, but you do want to insert the override annotation. So press OK. So the override annotation is going to tell IntelliJ that you overrode the equals method. So if you actually do something wrong with it, you're going to get an error. So it's basically helping you by giving you an error when you do something wrong with it. So here are the 2 generated methods. Now, obviously, we want to adjust this string. And the other thing we want to do is change this. Now, if you're comfortable doing all this yourself, like I'm super comfortable with just coming here and typing out string.format and then typing out my own string, you can do that. The equals method is something I prefer that you do on your own. But if you would have chose the other option, the code would have been written for you. So I'm going to right click, go to generate. This time I'm going to hit Tostring, and I'm actually going to tell it what I want to include in the Tostring, and I'm going to press OK. And there is my override for my Tostring, so it actually created it for me. I didn't have to do anything. Now the equals method will do the exact same thing, but I don't want you to do this because I want you to learn how to write your own equals method. But if you right click, go to generate, and then go to equals and hash, press next, and then select what you want to compare. We'll just take both of these variables, hit next and next. Here it's wanting to know if you're accepting null values. We hit finish and actually created a lot of the code for you. Now the reason why I don't like for students to do this is because this is confusing to some students and I feel like they don't actually understand what's going on. So the best thing to do is to create your own equals method. To create your own equals method, the first thing you want to do is you want to check to see if the object being passed in is a dog object. So I'm going to use an if condition check, and I'm going to check to see if O is an instance of the dog class. If it is, then I know that it's a dog object, and I can cast as O to a dog. So now that I converted the object into dog, I can do my comparisons. But the first thing we can do is we can just compare ages because we know that's never going to be null. We can do something like this. I'm basically just seeing if these 2 numbers are equal to each other. So if they are equal to each other, then I need to check the name. The name is an object, so it could be null. So I'm going to want to do a null check on that first. If this is false, meaning the 2 ages don't equal to each other, then we're actually going to come out of this if statement and return false here. So here's how I'm handling the name. So for this object, I'm checking to see if the name is null. And the other object, I'm checking to see if the name is null. If they're both null, I return true because this means the age was equal and both names were null. So then I do a check to see if the current instance where this method is being invoked on, if that name is null. So if it's not null, then I can go ahead and do this check here. But if it is null, then we're going to go ahead and return false right here. So at this point, we know that this string is not null, so we can invoke the equals method on it. We can pass in the name of the other dog object. What it's going to do is comparison on this. We have the equals method on the string class. We also have the equals ignore case if you didn't care about case sensitivity when comparing dogs. But I'm going to go ahead and just stick with the equals method. So this is how we create the equals method. Now I know this might seem a little difficult. I want you to get used to doing this. So now let's go ahead and generate our sphere class. So for the sphere, we just need instance data for diameter. So for the sphere class, since I know my only instance data is diameter, I went ahead and auto-generated my constructor, my getter and my setter, my toString method, and I generated my equals method, but I'm gonna have to go in here and modify this. I'm gonna go ahead and set that up. So the first thing I wanna do is I wanna check to see if the object being passed in is a sphere. And then once I know that this object's a sphere, I can go ahead and cast it to a sphere. And because the sphere only has instance data for diameter, this is actually going to be really easy. I'm just going to return the comparison of the diameters. Now this might actually seem correct, but there's one thing that we need to keep in mind. Since diameter is a double, how much of a tolerance of that double would you consider these two diameters to be equal to each other? This equals right here is actually checking to see if they're the exact binary representation of each other. Now in some cases, if diameter is 4.5 and this is 4.5, it might not actually be equal to each other because somehow the binary representation of those aren't actually equal. So the best thing to do in this case is to do a tolerance. So if you look through my Java 1 lecture videos in chapter 5, we do a section on comparing data where we talk about this. So the best way to handle this is to do an absolute value of the difference. So now what I'm doing is I'm taking the absolute value of the difference of the two diameters, and if they're within 1/1000th of each other, then we're going to return true. So if you look at our coding standard, it's always best to put numbers like this into a constant. So I'm going to go ahead and do that. So I made a constant called diameter equals tolerance. I use the final modifier, so that means it's a constant, it can never change. And I set it equal to 1/1000th. So I can go ahead and replace this here with the constant. So the next thing that we need to do for both the dog and the sphere is create Java documentation. That's something that we didn't do. If you're unfamiliar with how Java documentation works, you should go ahead and watch the lecture video that I did for my Java 1 class where I talk about Java documentation. But in IntelliJ, you can actually auto-generate some of the Java documentation. All you do is just go to where you want to add your Java documentation. So let's just say I'm going to add Java documentation to this constructor. I'm going to use a slash and then 2 stars, press enter. And because I'm passing in a diameter, it knew to use this Java doc tag. This is where I'm going to put in my description. And this is where I'm specifying what value I'm going to pass in. So here's my Java documentation. It's always good programming practice to create Java docs in your blueprint classes. You also need a Java doc comment for our class. And you're going to just come up here and you're going to write a documentation of what the class does. So the other things you need to do is you need to write Java documentation for all of these methods. I'm not going to do that. I'm going to leave that up to you. The other thing that we didn't do for this sphere class is we didn't calculate the volume or the surface area. I'll leave that up to you. But let's go ahead and talk about the driver class for these two. So in your homework, you should actually have multiple files in here. And then you can have one class that's going to run all your programs. So I'm going to go ahead and make a driver class, and I'm just going to name it driver. So in this driver class, I'm going to have my main method. So I'm going to go and just type in main and then use autocomplete in IntelliJ. You need to actually make static methods for each blueprint class you're going to test. So I'm going to go ahead and make a static method for my dog class, which is going to test all the methods of my dog class. Alright, so I made this static method called runDogTest. So what I'm doing is I'm testing all the methods in my dog class. And I just want to verify that they all work correctly. So I instantiate 3 dog objects. Then I print them out. This is going to invoke the toString method. Then I check to see if D1 is equal to D3. It's going to give me my value. That should return false. Then I set the age for D1, the age for D2, and then I set the name for Spot. Then I go ahead and print out all this information here once again so they can see my changes took place. And then I'll go ahead and do a check again with D1 and D3. Now this time I'm expecting them to be equal to each other because I set D1 age equal to 3, which is the same age as D3. And then I set D3 name as Spot. So now they both have the same name and the same age. Then the last thing I do is I make sure my getters work. So for D2, I print out the name, the age, and then I print out the age in human years. So I want to go ahead and run this program, but in order to run this program in my main method, I have to invoke the run dog test. So I'm going to go ahead and do that. So here are my results. You can see these are my toString methods. D1 does not equal D3. Then I made those modifications where I changed Spot's age to 3, and I changed Fido's age to -1, and I changed Leo's name to Spot. So now D1 and D3 are equal to each other. Then I print out Fido's information. His age is -1. His age in human years is -7. Okay, so entering negative values for age does not make any sense. So this is where in the instructions I talk about filtering out bad data. So what we want to do is we want to go into our setters and make sure that we cannot actually accept a value that is invalid. We should also do that in our constructors. So in order to do that, we need to use an if statement. So in my setter for my age, I'm going to go ahead and set up an if condition. As I'm making sure the age being passed in is greater or equal to 0. If it's not, then I'm never going to set age to that value. So I want to go ahead and do the same thing for my constructor. But really what I could just do in my constructor is just call my setter here. And if this is a bad value, it's not going to accept it and it's going to use the default value. I can specify a default value up here of 0, but Java automatically sets any numeric values to 0 if you don't initialize them. So I'm going to hop back over here. I'm going to update my test. Okay, so I updated my test to include another dog object. So I'm immediately passing in a negative value for my age for this new dog that I added, and then I'm printing out the value right here. And with my new if condition, this should not accept, and it should remain its original value. So I'm going to go ahead and run this program. And here are my results. You can see for my new dog, Bob, his age was 0, so that means the negative value didn't take. And then you can see for Fido, his age remained 7, so that -1 didn't take. So then here's the results at the bottom of Fido's name, his age, and his age in human years. So what I want to do in my driver is set up another static method to test my sphere class. So I went ahead and added all the tests that I want to do. So I created 2 sphere objects, print them out. That's going to test the toString method. And I check to see if sphere 1 and sphere 2 are equal. I'm passing in 13.02. And I'm passing in a negative value. I want to see if that actually takes. And then I print everything out again, check to see if they're equal. Then I adjust my diameter for sphere 1 to 12.99999. Now remember, we have a tolerance of 1/1000th, so I'm expecting this to return true. When I do this check down here, and then I'm checking my getter methods for sphere 1 and sphere 2, and I forgot to change this to sphere 2. So I went ahead and set a default value for my diameter to 1. And in my constructor, what I do is I just call my setter for diameter. Now if you look at my setter for diameter, I'm making sure that the value is greater than 0, because it doesn't make sense for something that is a measurement to have a value that is 0. So how can a sphere have a diameter of 0? That just means there's no measurement, so it's not really a sphere. So I want to make sure diameter is actually greater than 0 before I take that value in as my diameter. Now because I updated how my sphere works, my description for my constructor and for my setter in my java.comment should be updated as well. So here is the statement that I added to my java.comment. And this is important because it's telling me how this class actually behaves. So if I pass in a diameter to 0 or less than 0, then the sphere is going to have a diameter of 1. So I'm going to go ahead and run this program. I updated my main method to run the sphere test. And here are my results. You can see when I try to pass in that negative value, I get a diameter of 1. And sphere 1 and sphere 2 are not equal to each other. Then I set diameter of sphere 1 to 13.0 and I try to pass in a negative value here. It didn't take. These are not equal to each other because these are not within tolerance. So I set diameter of sphere 1 to 12.9999. That is within my 1/1000th. So this is returning true. So this is how I want you to test your driver class all in one project. Now the next thing we need to do is in our main method, we actually need to create a menu. I'm going to go ahead and do that. All right, so I went ahead and created my menu. So in order to do this, I did need to use a scanner class. I created this char variable to retain the menu option that the user enters. Then I print out this really nice menu. I store the char into my variable menu option. So this is what I'm doing to pull out my char. So I'm taking the next line, I'm trimming off the white space, taking it to uppercase, and then pulling off the first char. Now this will crash if the user enters in no data. If the user just presses enter, then the string has no characters in it, so there's no char at 0, and the program will crash. So we're going to go into a switch statement, and we're going to examine our menu option. If it's D, we run the dog test. S, we run the sphere test. Q, we quit, we say goodbye. And anything else, we just say that is an invalid option. And this is in a do loop. So this do loop is being controlled by this statement. So while the menu option is not Q, you're going to keep running this loop. Now one thing you'll notice is the switch is highlighted. If I hover over this, IntelliJ wants me to use the enhanced version of the switch statement. Now the enhanced version is going to use lambda expressions. We're not going to talk about lambda expressions in this course. It's something that you can study on your own if you wish to. If you want to change this to a lambda expression, you can just click on replace with the enhanced switch statement. So this is basically the same thing as what I had before. It's going to run exactly the same. Now I'm going to avoid doing this, but this is an option if you want to do it. But this actually makes it a lot less to deal with. But I'm going to go ahead and put it back to the way I had it. And this is the way that it's taught in the Java 1 class. So I'm going to go ahead and run this program. So the first thing I want to do is I want to enter in no data. So I'm just going to press enter, and then we can see the crash that I was talking about. So you can see that the string that I entered had no characters in it. So try to grab the character at index 0, which was not there. And I got a string index out of bounds exception. I'm going to go ahead and run this again. So I want to verify that I can actually leave this loop. So I'm going to type in a Q, and I get goodbye, and then the program ended. Next thing I want to do is I want to verify that I get the invalid option. I'm going to type in an option that's not valid. It told me it's an invalid option, and now I'm getting the menu again to enter something else. I'm going to type in a number, invalid option. So now I'm going to go ahead and enter in a valid option. I press D to run the dog test. You can see that my dog test ran. Now I'm going to run my sphere test, and you can see that the sphere test ran. So this is what I want you to do for the homework. It is a lot of work, but a lot of what we did over here was auto-generating a lot of this stuff. So a lot of the work is going to be in making the Java documentation and then coming in and doing filters on your setters. Don't forget to handle your equals method. Now I do want you to do this on your own. I want you to get that practice because this is something that you're going to see on your midterm and also your final.